Hello everybody. In last two modules, we have gone through fundamentals of electromechanical energy conversion, then power electronics converters. Now we will start control theory. Now in a complete drive system, there is a DC source, then a converter, then motor. The source may be DC or AC based on the type of motor. Now the power electronics converter converts the input to usable form of output, which is fed to the motor. Now in some cases it happens that desired output speed or some of the parameters of the complete system is not within our control, then closed loop system is required. So today we will discuss about control loops, control theory or closed loop systems, or the types of control system used in electrical drives. So let's start. The control theory. An electrical drives operates in basically three modes. Steady state, when the torque developed by the motor is equal to load torque. Then acceleration including starting. Deceleration including stopping. A motor generally drives a load through some transmission system, and the transmission system may be rotational to rotational transmission system or rotational to translation system. Rotational to rotational generally achieved by using gear drive system. Rotational to translational can be achieved by using some conveyor belt arrangement or pulley arrangement. Now, while motor always rotates, the load may rotate or may go translational motion. Load speed may be different from that of the motor. As we are using gear drive system, so the load speed can be increased or decreased compared to the speed of the motor. And if the load has many parts, their speeds may be different. And while some may rotate, others may go through a translation motion. So gear drive system or pulley arrangement we can use to obtain desired speed of the load, though the motor is rotating. Now this is a block diagram of motor load arrangement, but in this case there is no transmission system. Directly the load is connected to the motor. The shaft of the motor is connected to the shaft of the load. Now this T is torque developed by the motor. The speed of the motor is in this direction. Now the load torque is always opposite to the driving torque. Now what will happen if driving torque is more, load torque is less, or if the load torque is more, driving torque is less? So in that case, what will happen to the speed of the composite system? So to explain this one with a basic equation, let's see. Let's assume J as the polar moment of inertia of the motor load system, referred to the motor shaft. So polar moment of the system, complete system, referred to the motor shaft is J, and the unit is kg meter square. Omega m, instantaneous angular velocity of motor shaft. The speed of the motor as well as load is omega m. T is equal to instantaneous value of the developed motor torque in Newton meter. T. TL is the instantaneous value of the load torque referred to the motor shaft, Newton meter. So TL is referred to the motor shaft. It includes friction and windage torque. So here across the mechanical system of the load system, some friction as well as windage torque is also there, and that is included in this TL. The motor load system can be represented by the following fundamental torque equation. So this is very important fundamental equation, that is T minus TL is equal to d dt of J omega m. So J is polar moment of inertia, and it may change, but for simplicity here we are assuming that J is constant. In some of the cases, like in flywheel, J is variable, but here we are considering J is constant. So d of j omega m dt is equal to j d omega m dt. Now, from here we can see that if the driving torque is more than the load torque, then j d omega m dt is positive. It indicates that motor will accelerate, or the speed of the motor will continue to increase. Now, if TL is more than T, then d omega m dt is negative. It indicates that speed of the composite system will reduce. Till what point? The point at which d omega m dt becomes 0. That means motor rotates with constant speed. That means at that point T will be equal to TL. That means driving torque is equal to load torque. Then equilibrium point is achieved. Now this can be explained with the help of this graph. So this is your dotted line is torque speed characteristics of motor. This one is torque speed characteristics of the load. Now let's assume we want to operate at this point. So at this point, developed torque is more than the load torque. So T minus TL is positive. That means composite system speed will continue to increase. So the speed is along this direction. So speed will increase. And the speed will increase till this point. This is your T and TL. So at this point, driving torque becomes equal to the load torque. And at this point, speed of the motor is constant. So the motor will rotate with constant speed omega m. So that because of that constant speed, d omega m dt becomes equal to 0, and that driving torque is equal to load torque. So this is the steady state point, or you can say the equilibrium point of the system. So it may be that at the time of starting, load torque is more, driving torque is less, then the complete system will not start. So anyhow we have to increase this driving torque so that desired speed we can obtain till T is equal to TL point. Now the motor torque characteristics may be different for different motors, as well as the load characteristics may be different for different types of applications. But ultimately T is equal to TL will be the equilibrium point we have to achieve to run the motor at constant speed. So at equilibrium point, d omega m dt is 0 and T is equal to TL. Now in some cases, to achieve this T is equal to TL, closed loop control is required. In some cases, open loop is sufficient to achieve this state or the required output speed. Based on this one, let's see. Here there are some terminology used to refer the different types of drives. Some drives may be adjustable speed drives, some constant speed drives, some multi-motor drives. So those things are there. So these types are mentioned here. So drives where the driving motor runs at a nearly fixed speed are known as constant speed drives. Multi-speed drives are those which operate at discrete speed settings. In these multi-speed drives, different desired output speeds can be obtained. Now, drives needing stepless change, that means a smooth change in speed, and multi-speed drives are called variable speed drives. Variable speed drives can be of various types: constant torque speed drives or constant power speed drives. Now, when a number of motors are fed from a common converter, as I told you that in a complete drive system, there is a source, AC or DC, then converter is there, then motor is there. Now from the same converter, if number of motors are connected, output of the converter is connected to different motors. Or when a load is driven by more than one motor, the drive is termed as multi-motor drive. A variable speed drive is called constant torque drive. This variable speed drive, as I told, are called constant speed drive if the drive's maximum torque capability does not change with a change in speed settings. That means maximum torque capability of the motor or rating of the motor remains same. So the motor will not cross this maximum torque or the achievable torque from the motor. In that case, the drive is known as constant torque drive. This can be also called as variable power drive because power is equal to torque into speed. As the torque we are assuming that is constant and the speed is changing, so the power is variable. Ideally, for a given speed setting, the motor speed should remain constant, but it is ideal. Ideally, for a given speed setting, the motor speed should remain constant as load torque is changed from no load to full load, but practically it is not possible. Some drop in speed or decrease in speed usually takes place when the motor is fully loaded. So the speed drops with an increase in load torque is represented by speed regulation of the system, and the speed regulation is equal to no load speed minus full load speed by full load speed into 100%. For particular drive system, this speed regulation is set, and the complete drive system or closed loop system is designed to obtain that speed regulation. If open loop control fails to provide the desired speed regulation, drive is operated as a closed loop system. That means some parameter you have to sense from output side or from the input side, and we have to monitor this one in such a way that we will get desired speed of the load or motor. So let's discuss a little bit about that closed loop system. Now the closed loop system may be feedback or feed forward control system, and it is generally provided to satisfy one or more of the following requirements. First one is your protection. For protection point of view, also sometimes this closed loop system is used. Enhancement of speed of response. Quickly the speed should attain its desired speed after any disturbance in the system or any change in the load or source side. To improve steady state accuracy. Now this is a block diagram of current limit control. Now the current limit control is nothing but to control the current of the converter or current of the motor to operate within its rating. Every converter has some number of switches, and the switches has its own rating. So within the rating of the converter or rating of the switches, the devices should operate, otherwise the complete drive system may get damaged. At the same time, current of the motor winding should be within its safe limit. So to get that one or to ensure that one, this system is developed. So here you can see, here is a current sensor. It senses the current flowing through the motor. Now this V star is nothing but desired output speed or based on the desired output parameters. This is the reference value. Now from the sensed value or the sensed current, it is passed through a logic circuit. Here it is compared that whether the sense current is within the maximum limit I max or not. If it is within the maximum limit, then it will not disturb the drive system. If this current is more than I maximum, then it will generate a signal, and this signal is subtracted from the reference value and fed to a controller. This controller may be proportional controller, PI controller or PID controller, and the output of the controller is fed to the converter switches in such a way to obtain the desired output or to limit the current flowing through the motor winding. Generally, it has been seen that at the time of starting, motor draws more amount of current, and that current may be more than the rated current of the motor winding. So at that point, this current is more than the I maximum, then this portion will be activated and controller will generate some pulses or some signal for this converter switches, and the output will be limited. So what will happen at the time of starting, frequent fluctuation of this current will take place. So initially the current is more, then this will be brought down to safe limit, then again the current will increase, again it will be brought down to safe limit. So this fluctuation will be there until current is within the safe limit. So after achieving steady state, current automatically reaches the safe value and the closed loop system is deactivated. So the purpose of this closed loop system is just to ensure that current should not increase more than the safe limit or the rated limit. When it is within the safe limit, the controller will not disturb this system. Okay. So it is required to limit the converter and motor current to a safe limit. It has a current feedback loop with a threshold logic circuit. So this logic circuit will compare that whether the sensed value is within the safe limit or not. If not, then it will actuate this system and the controller will generate some output, and that output is fed to the converter switches to limit this current. So as long as the current is within a set maximum value, feedback loop does not affect operation of the drive. During a transient operation, if current exceeds the set maximum value, feedback loop becomes active and the current is forced below a set maximum value, which causes the feedback loop to become inactive again. So during a starting, current will fluctuate around the set maximum value. So around this point at the time of starting, it will fluctuate. So when it is more than this one, then it will be brought down to I maximum or less than I maximum. Then again it will increase, then again it will decrease. So like this fluctuation will be there till current is within the safe value, and it is at the time of starting. So after starting, when motor reaches the steady state speed, at that time current is less than the rated limit. Generally at the time of starting, what happens, 2 to 2.5 times current is drawn by this motor from this system. So just at the time of starting, this phenomena will be there, or at the time of any fault in the circuit, this will occur. This system is just to ensure that motor and converter should operate within safe limit. So this is a very simple circuit to obtain the desired current or the desired speed. Okay, so today just we have discussed about closed loop system, current limit control to ensure that motor and converter should operate within safe limit. So closed loop system is generally used to protect the device from overcurrent or any other disturbance in the system or in the transient state. It may be used to obtain the desired speed of the motor. So there are various closed loop system based on the requirement. There may be number of closed loop system in a complete drive system. One closed loop may be for limiting the current, another may be to limit the speed, one more may be to limit the output voltage of the system. So many closed loop system may be there, but if number of closed loop system increases, then the complexity of the system increases and its control becomes very tough. At the same time, cost of the system increases. We have to be very cautious in deciding what parameters are important for that application, and accordingly we have to develop the control system. So in coming classes we will discuss some more closed loop system. Thank you.